And so we'll hit start recording. Great. Okay. So remember how I mentioned that when we were talking about modular arithmetic, we're doing a lot of fourth grade math, right? We're going to do more of that today. Lots of basic mathematics today, although we're going to stretch a bit into high school geometry today because that's what we're focusing on today, geometry. Well, in reality, what we're focusing on is turtles, teaching you how to use turtles, as well as our first introduction to for loops. So for loops are basically the topic for the first exam. So over the next couple of weeks, we will be basically doing exercises that work on making sure that you master the way for loops work. We'll be working through them in kind of different layers of complexity and the different functions they have. They all follow the same format, which is fairly easy to read, but we're just going to introduce them today as easily as possible, as straightforward as possible. So what we're going to do is we're going to go to Canvas, or you can go directly to Runestone if you prefer, right? Because all we're doing today is work in Runestone. And I ran the grader on the first week's worth of stuff, so so come to me after class if the in-class exercise from lecture 2, so the active learning exercise, doesn't work, doesn't have the right grade, or if chapter 1 reading or chapter 1 exercises has the wrong grade, right? Those are what I would want to check. Over here, what we're going to do. So first way to get today's exercise, again, we're doing it all in Runestone, is that you can go to Runestone, log in, it'll bring you to our course. And then what we do is we click on Foundations of Python Programming, and we scroll all the way down to the appendices, except we hit Acknowledgement, so we scroll a bit back up. And then we go to Exercise 4, which is Drawing with a Turtle. The other way to get there is if you're on Canvas, you go to Introduction to Problem Solving, and this is what you always do if you come in late and have no idea where we are. We go over here to Modules, right? And then we go over here to, we're at week 3, so Module 3, Debugging in Libraries, and this talks about different things to do. Again, these two chapters on debugging and importing libraries are fairly short, although the video number 2 is actually one of the most viewed videos on my channel because of how many people who are not in this class stumble across that one, because it is a very common issue, which is that if you're trying to import a library like Turtle, don't name your file Turtle. It confuses Python. So that may not make sense, but it will be an error that I'll correct for at least one of you. So don't worry about if that happens to you. It's common. Okay? So the list, remember, the listed readings are these readings. Again, click on them. It'll bring you to the entire list. And we want to have chapter 3 readings done. The quizzes are old things that I just never deleted because I still want to have the questions on hand. They're not going to show up for you. They show up for me because these quizzes are literally from COVID when I basically had no way of proctoring. So, but the questions I came out with are still useful. Anyway, chapter 3 and chapter 4, they're fairly short. I don't even think there's exercises for them. And then chapter 5 readings for the Turtle lab will be used on lab 3, lab 4 and 5, and lab 7. So what we're going over today is fairly important, but it's also fairly straightforward. Okay? Anyway, right, to get to today's exercise, go to Modules, click on Module 3, which is Debugging in Library. You scroll down, and then you click on Tuesday, we will do project first from the textbook, and I've fixed the URL. I typically do that before class to go to this semester's thing. So we've got our exercise, which is drawing a circle with the turtle. Now, the idea here is that, yes, there is a function that is built into Turtle that allows a turtle to draw a circle. Now, for those of you who have missed lectures or or have forgotten because it's been a very busy first 2 weeks, right? You know, it's a lot of you, it's your first semester at college, so it's can be very overwhelming, and there's lots of things going on. So what is Turtle again? Turtle is a library that was created, that is based off this concept we have for programming languages called turtles. The programming language was called Logos. It was made in the 60s, I think. It's not really important. The important thing is that this library that's been recreated for a bunch of programming language called Turtle is this nice paradigm we have for teaching some basic graphics. It also allows us to easily visualize these pedagogical concepts. So the way we use it, it requires two magic lines. I try to avoid magic, what I call magic, as much as possible in these lectures. What do I mean by magic? If we were working in Java, you need to have a bunch of magic lines at the beginning of your program before we could even start programming. For example, we would need to do we'd have to do public class hello, where this needs to match the name of your file, okay? And then I'd have to have this other bit, which is public static void main string open bracket close bracket args, and every single part of this is mandatory for every program that you write in Java. And I literally have to say the first day of class, just memorize these things. I will explain it. It will be all will be explained by the end of the semester. And all these things are explained by the end of the semester. But that's annoying, right? You don't like to have to do things that don't really have an explanation. What the heck's a static? And why are we going args as opposed to anything else? And why does the word string have these weird bracket symbols, right? Why do we do that? And why do we have these little symbols? The curly braces, as we call them. Nobody uses those. I've never had you don't have to use them in anything but programming. Why are we using them here? So I like Python because for doing turtles, I really only have 2 lines of magic, and at least I can explain what the magic is doing, as opposed to saying, let's do it later. So the first line of magic is import turtle. And if you've watched or read about chapter 4 about libraries, you'll know that what this does is that there's a pre-built library in Python called Turtle. It's code that's already been created, part of every deployment of the Python programming language. So when you install Python, you got this for free. It basically allows us to do all these turtle operations. If you didn't have this, Python would basically go, what the heck are you talking about? I don't understand any of this turtle stuff. And the reason that it doesn't get loaded up automatically with every program is because otherwise that would make all of our programs take way too long to boot and become unreasonably large. Okay, the next thing we do is this other line where we actually make a turtle, okay? And on the right side of the equal sign is the bit of the magic where we make a literal turtle. We say turtle, which is the name of the package, dot to say this is what's inside the package, this is what's inside the library, and then capital T turtle. This is the only bit of magic that we have to do that I won't be able to fully satisfy as to why this is what you do. But what this does is that this creates a new turtle. This creates a new turtle in the same way that you typing a number creates a new number, or you typing in a string creates a new string. Okay? This is just the magic phrase you use to create a turtle. And a lot of stuff goes on underneath that. And so this is what's going on the right. It creates a new turtle, and then we store that in the left. We store it in the box on the left. Another way to think about it is that we are creating a turtle, and we are applying the name tag Bob to it. We are just sticking the name tag Bob onto it so we can say, Bob, do this, and then the turtle's going to do that. Why do I do Bob? Because it's 3 letters and 1 syllable. That's why. And it gives it a name. It personifies it. Okay? Makes it easier to just simply do stuff. Okay, so, and then to remind you what do these things do, turtles are very basic for doing things. You can tell them to move forward, and they'll move forward. All right, I'm going to just zoom out for a second. It will move. If you tell it to move forward, it'll move forward. If you tell it to move backward a certain distance, it will move backward a certain distance. What does that forward and backward mean? Forward and backward, sorry, what does that number mean in forward and backward? That's the number of pixels to move. By default, this window is 200 pixels by 200 pixels, right? So pretty small window, but big enough for our purposes, right? Pixels, again, are those tiny little squares on your screen, or the tiny little squares in an image. The other thing we can do is that we can tell it to move forward, and then we can give it more commands. Like I could tell it to go forward twice, forward, forward. I could tell it to go forward, then I could tell it to turn left or right. Bob.right, and then inside the parentheses is, again, an amount. Now, the amount represents the least surprising thing, which is the number of degrees it's going to turn to the right in this case. If it was left, it would turn that many degrees to the left. So let's go ahead, zoom out again, and run it. Bob, turn right 90 degrees, and then he moves forward again. So basically, you move the turtle by telling it to go right, right and left. As I mentioned on, I think it was last Tuesday, very end of class, the way this paradigm works is that imagine you're taking a bird's eye view of this giant canvas, this giant painting or piece of paper. And on it is a turtle. In fact, I'm going to go and just be fun and say, I think it's bob.setShape, or bob.shape. Let's see, I always have to look it up. And then I'm going to say turtle. I believe this works. And that'll turn it into actually looking like a turtle. It has literally no effect on the programming, but what this did is that this made our little guy look like a turtle. See, bob.shapeTurtle. Turned him into a little turtle shape. Okay, so anyway, we're taking this bird's eye view of this piece of canvas, this piece of paper, and it's got a little turtle on it. This little turtle has a paintbrush or a pen attached to its tail, and as it moves, it is dragging this along the paper, and it is drawing it, right? So you just give it directions to get it to draw. You tell it to move forward or backwards, and you tell it to turn left or right. There's also two more commands that we're not really going to use today. All we're going to use today is like forward and turning. The other commands are, we are going to go and turn, let's see, is that we are going to tell it to do bob.up, which does not tell it to move up, which is mildly confusing. It tells it to lift its tail up. So bob forward 100, bob.right 90 degrees, bob.up. So it moves forward 100, turns right 90 degrees, turns like this, and then he tells it to lift its tail up. So it's no longer dragging its tail along the paper, so it's now just simply just walking. And that's why when we tell it to move forward again, it doesn't draw anything. Make sense so far? Right? So this is extremely useful for doing a lot of like visual stuff without having to really dive into the way a lot of nasty kind of matrices that graphics typically require. We're just simply giving a turtle directions, and this allows us to do some nice things with geometry and angles and making fun shapes. There are a lot of fun stuff you can do with turtles. Now, it does have a ton of built-in functions to it, as we'll see. But one of the big ones today is there's a built-in circle function, which you can use to make it draw a circle. But we're not going to use that today. Instead, we're going to kind of look at how in the world do you draw a circle on a computer anyway, right? So what we're going to do is we are going to use, this will be fairly straightforward until we get to the end, because there will be some conversions that you may not be used to that might not flow naturally, because you don't normally think of how do I turn a shape into a circle kind of thing. But we're going to start out simple, which is our objective right now is to draw a triangle, okay? We're going to ask the user for a side length and then draw a triangle. What do I mean by that? We're going to ask the user using the input statement, and we're going to tell it to then draw a triangle. Now, while you are given lots of options to draw a triangle, right, let's open up the whiteboard because I'm going to do a lot of drawing today. Okay? Well, there's lots of ways to draw stuff. Like, new whiteboard. Whatever. Okay. So this was from something else. Doesn't matter. While we could draw this, there's nothing stopping us from drawing a triangle like this. But this triangle over here is a bit harder to do, in my opinion. Right? It's easier to make what we call an equilateral triangle. Right? One where all the sides are even and all the angles are even. About. Okay. So what we're going to do is effectively ask the user how big the side is. Now, you might be asking, how do we do that? Well, first we use the input statement. The other thing to realize is that anywhere that I'm using numbers, I could use a variable instead. I could say side is equal to 50, or in this case 100, and then anytime it moves, I can instead tell it to move side variable amount. And we'll get the same response, right? All I did was give it a side. But rather than, just simply getting the user, rather than just simply defining it, we're going to let the user do it. So how do we do that? We do that by using the input statement, right? And we say, enter the size of the triangle's side. Okay. And then I'm going to run it, and then it's going to crash. So I'm going to tell it to go 100, and then hold on a second. Did it run or no? Let's see. Run 100. Oh, no, it went. It went just fine. Apparently it does that. But really what I should be doing is int to convert it into an integer. Interesting. Did it just automatically convert? Does it do that automatically? I gotta check this out, sorry. Apparently it's smart enough to say, hey, if that's a string, I'll just turn it into an integer and work with it. Nice. Good job, Turtle. So we'll go ahead and give it an integer anyway. We tell it how big it is, and then we tell it to move forward. And then if I give it 100, it's going to move forward 100. And if I give it, let's go with 12, it's going to go 12. As you can see right here, it barely moved at all, right? So what we're going to want to do is we're going to want to use this to draw a triangle now. Use the turtle. So your task right now is to use the turtle to draw a triangle. Now, let's assume for a second that we start right here. You're thinking, why can't I just get start? I know how a triangle works, especially if it's an equilateral triangle, right? What's the internal angles of a triangle add up to, right? What's that? These angles, what do they add up to? 180. So if they're all equal, these internal angles are 60 apiece. So I should tell the turtle, and so then you immediately go, based off this knowledge, that you should tell the turtle to turn 60 degrees. But let's think about that for a second. If I tell the turtle to turn, if I'm going this way and I tell it to turn left 60 degrees, how much of a turn is it making? Left. So this is 90 degrees, right? This would be 60 degrees. Around, right thereabouts. And then, so let me go ahead and demonstrate that. This would be about 60 degrees. That would be our 90 degree turn, approximately. This would be a 60 degree turn. Now we're here, turning left, this is 90 degrees. And this would be a 60 degree turn. So, what happened? Did our math teachers lie to us? No. We're just having we're just having an issue with separating out multiple different numbers. Okay, here we are. The issue is that this is for helping us figure out what the internals of a triangle are, and we actually don't really care about the internals of a triangle too much. What we care about is that, right, if we're drawing an equilateral triangle, all the sides need to be the same, all the angles need to be the same. So I move forward, and I need to turn this amount. Now we know that this amount is 60 degrees, that this angle is 60 degrees, so I need to turn whatever this amount is. What was that amount? 120. I heard a lot of you mouthing it. I heard a lot of you mouthing it. Or saw a lot of you mouthing it. Yeah, this amount is 120. So that's the angle you need to go for, 120. With that knowledge in mind, go ahead and write a program that draws a triangle. And if you do it right, basically it's going to be the same three lines repeated. So it's going to be the same lines repeated 3 times, right? To draw and turn, draw and turn, draw and turn. I don't particularly care which way your turtle faces, up or down. I'm going to draw mine up, but it doesn't matter. If you got a turtle, if you got a triangle, I'm happy. Just waiting one more minute. All right, so if you got it, great. If you didn't get it, don't worry. I'm going to give you the answer right now. So the first 4 lines basically are going to be almost exactly the same for the rest of our exercises. They're always going to be import turtle. Bob is equal to turtle to create our turtle. Bob.shape is just simply completely optional. That just simply makes him look like a turtle, and that makes me feel warm and fuzzy on the inside, so I do it. And then this part is always going to be the same, which is asking for a side length. The only difference is that when we move up to a different shape, we're just going to put the name of a different shape in for the user. Make sense? So here it's triangle because we're trying to draw a triangle. Now, how do we draw a triangle? Well, let's start by drawing a line. So Bob dot Ford 100. Or not 100, but side, the amount the user puts in. Now, turtle by default always starts facing to the east. He always faces this way. So what he's going to do is he's going to basically move this amount, right, and end up kind of over here. Right? He's going to move this amount, end up over here. And he's still facing this way. So now, for our next turn, to draw the next part, we have to get it to go over here. And I kind of explained, hey, what we want to do if we're drawing an equilateral triangle, right? We want this angle to be 60 because when we draw a triangle, all these angles are 60 degrees, right? But since we're facing this way, right, in order to get that, we have to draw this, we have to turn this angle. So we're facing this way, we have to turn this way, right? And to turn this way, well, this is 90 degrees, so we got to go a bit beyond that. And if you remember your high school geometry or college algebra stuff, this is basically if you want to turn around fully, that's going to be 180. So this amount is going to be 60 plus whatever amount that is. So 180 would be 60 plus whatever amount this turn is. So 120 over here. So what we do is we tell Bob to turn in some direction, in this case left, 120. If you did right, you're just going to get a downward facing triangle, and that's fine too. So forward, 100, and now I'm going to go here, and we notice that the turtle is which way the turtle is facing now. It's facing that direction. So we're going to tell it to move forward again. I'm just going to copy and paste this line over here. 100, and there. And now it needs to face it this way, and so we got to just simply get him to turn this same way. Again, it's a bit harder to see because he's not going he's going diagonally now, so it's a bit harder to see the lines, but if we simply tell him to turn left 120 again, and I'll go ahead and do maybe 150 this time around for giggles, and we now see that he's lined up to draw this last line. And we'll do, again, whoops, that's a bit too big, my bad. See, I accidentally did 1150. So it's running. Now, if you ever get into a result like this where it runs for a long time, the program, oopsie, it did draw the rest. If you ever get into this situation where the program will run a long time, the browser is set up to crash automatically, the program is set up to automatically crash in 30 seconds. So there's no way that it locks out your computer, essentially. So if you accidentally write what we call an infinite loop, we'll get that. So here we have a triangle, and what I'm going to do is I'm going to add one more turn to the left. Why? Because first off, you'll see that when I do this is just a habit I want you to get into, which is when we're drawing complex shapes, it's always useful to get the turtle back to where he started. Because if you're chaining complex shapes together, it can be very useful to remember to kind of think, okay, it's very useful to not have to remember where the turtle ended up. You can just remember it starts and stops at the same place. Very useful. Also, because it makes this extremely easy to break up. Draw the first part. Draw the second part. Draw the third part. See? Same thing. Repeat again. And third, 120 plus 120 adds up to 360, which is the amount for a circle, right? So when we're drawing these kind of shapes, the amount that we need to turn to complete it is a full circle. So this is kind of useful. All right, with that, what you've learned, okay, so now I'm going to go ahead and share this code with you just so that you have it. And now, yes? Sorry? If you got the same result, that's fine. Yeah, that's great. There's a lot of different ways to do it. There's a number of different ways to do it. But right here is what I wanted to just kind of show. So now I've shared this code with you. If you need this copy as opposed to your own copy to work with, you can just simply reload the page and it'll be there for you. But otherwise, you can just continue directly down and work on the next part, which is the exact same problem, but now we're doing a square, right? Square is again, that's probably even easier. And throughout today, we're going to be working with what are formerly called regular polygons, and what you kind of mentally classify as normal shapes, right? Basically, when I ask you to think of a four-sided thing, you're typically thinking of a square and not like a rectangle like this. So we're going to be working with regular polygons today. So work on this. Side length, draw square. I'm going to leave the triangle code up in case you need it as a reference, but you're working on a square. And to those of you in the future who are watching this recording, I'm just going to keep it running so I don't accidentally forget to unpause the recording. So feel free to fast forward until you see me again. This one was probably even easier than a triangle. Actually, it is easier if we would started with this one, in my opinion, but I understand the logic because we're going to be building up into shape complexity, or rather in the number of, not shape complexity, because the square in some ways is even simpler, right? But we're going to be working kind of towards more and more, or rather high, more and more turns. So 3 then 4 makes sense. So I'm going to just do it from scratch, just simply so that you can see it, in slow-mo, right? First thing we do, import turtle, right? We create our turtle, Bob is equal to turtle.turtle, and it's important you get that capitalization. This is what, it's capitalized because that's what you do when you create these things called objects, which is this entire class. You'll be learning about how to code and how to make your own verbs in the programming language, which we call functions. And the entire next class, 1068, is dedicated to writing nouns in our programming language, which are our objects and classes. So, and those are traditionally capitalized, so you know those are nouns. there you go. That's your preview of 1060 of the next class. Okay, so we create this object, this turtle thing, and then we say, Bob, this is completely optional. Bob.shape is equal to a turtle. There's a few other shapes, but I like to turn, if I'm working with turtles, I like seeing a turtle on screen. It's, silly, but I like it. And then we're going to ask the user for the side length, right? I'm going to go ahead and say side is equal to 100 right now, and then I'll replace that with the input statement. Why? Because I find it annoying to have to always pause and put in the number, right? I'm just going to leave the number set for right now, and I can test it with different numbers, but when my product is finally ready, I'm going to put in the input statement for the user interaction. That way, when I'm testing, it's just click, run, click, run, click, run. Nothing else has to happen. So I'm going to just simply say our square is going to be side 100. Okay. So what we need to do is to draw our it's always useful to game these out. Move forward, right? He's going to move forward, then he's going to turn 90 degrees in either direction, left or right, and then he's just going to keep so then he's going to move forward, then turn 90 degrees again, right? So turn right 90 degrees, so turn this way, and turn this way, and turn this way, and turn this way, right? Just turn 90 degrees. Make 90-degree turns. So bob.forward.side, and you'll see that I got a bit lazy there, right? I put FD instead of forward, right? That's a shortcut. Python Turtle totally lets you do FD instead of forward. They do exactly the same thing. Forward or FD. It's kind of useful for if you have to write the code on an exam, right? Having to write FD. If there's a shortcut for turning to the left, any guess what that shortcut would be? It's going to be 2 letters. LT for left turn. Or just simply that. I personally just want to let you know that that exists, but let's go ahead and just make it readable because it's just more effort for me. While it's more effort for me to type, it's actually less effort for you mentally to read more letters. Odd, right? And then all I'm going to do is I'm going to copy this 4 times because there's 4 sides, right? 1, 2, 3, 4, and ta-da! I'll share this right now, but I still got to work on here because it's here that I'm going to introduce our for loops. Because our next step, if we look forward, is making an octagon. And we're starting to get to the point where it's hard to kind of chunk. What do I mean by that? Humans have some natural limitations. Like working memory is like 4 to 8 objects, 4 to 7, 4 to 8 objects you can remember in your head if you're told to memorize something, and that kind of that's kind of the level where things are out beyond that level kind of stops being easy to memorize. Similarly, this is 1. You know that this is 2, right? You can just look at that and go 2. You can look at this and go 3. But around here, maybe, depending on the person, it depends from person to person, you go, that's 2 2s, so that's 4. Or you look at that and goes 4. That's what I mean by chunking. Some of you begin to chunk and go, that's 4. And what about 5, right? You probably can look at that because it looks like a dice and go, that's 5. I recognize that as almost a symbol for 5. Same for this, 6. This almost looks like this. But, and maybe 7. But at what point do you have to start counting, right? That these are, at what point do you have to basically look at a blob of things and go, oh, there's this many, right? And when we're getting to 7 or 8, it starts getting to that point where you have to start doing addition to count how many there is. Or literally just start counting and you can't just see it and go. Some people can, and that's cool, but, so I really don't want to have to do this. I really don't want to have to do this for this one where I go and then go 1, 2, 3, 4, 5, 6, 7, 8. What? Oh shoot! I lost count. Exactly right. That was. You get my point now, right? So we want something. So I want this code to be repeatable, and we do have a tool for that. It's called the for loop. Now the for loop always, always, always has a format. Okay, and we're going to work on that for loop. So the way a for loop works is that it has 4 parts. For loop has 4 parts. The first thing it has, the first and the third part are always the same. Okay? First part is the word for. That's why it's called a for loop. It's short for like doing for this many times or for everything in this. Okay? The second part, I'll come back to that. Why? Because I told you the first and third part are the same, so I might as well tell you what those are. The third part is the word in. And then it ends with a colon. Okay? I'll explain the colon in a bit, but the way it always works is for thing in collection. That's what we're looking for. For thing in collection. Okay? Now, that's the way it works on top. Right now, we're going to actually make it even easier and only have to think about 3 things. The for, the in, and the fourth part. This part right over here, part number 2 of the for loop, I'm just going to put an underscore here. And that's Python's way, that's a special Python way of saying, I don't care what that is. I don't need it right now. I don't care what it is. Let's ignore it. And that's what we can do. We can make it simpler for us and just ignore the second part. So underscore for ignore it, right? We just don't care about it right now. We'll learn more about that on Thursday, but today's Tuesday. Let's keep it simple. Right? For blank, the blank being I don't care, in something. And today, the something is this word, range, and then a number. Okay? Let's go ahead and see how that works. So for blank in range 5, I'm just going to go ahead and do print hello. And this should be fairly simple and unsurprising once we start doing modifications to this. I hit save and run, and I do hello. 5, 10, 100. So let's break this down. For blank in range, number means I want to do what's ever inside this for loop, this number many of times. So I'm just going to turn it to an easy to count number like 3 over here. Okay? And it does what's ever inside the for loop that many times. So let's just add some more code because this will make what I mean inside a bit more apparent. And you don't need this print done. You don't need any of this. It's just simply pedagogical stuff going on right now. So, in other words, stuff for the purpose of teaching you it. For blank in range 3, this is our for loop. And then we've got lines 9 and 10. So let's run it, and then we can work backwards to see how this works. Hello world, hello world, hello world, done. So what's inside the for loop? The things that physically look like they're inside the for loop here, right? So the way a for loop works is you've got these components. You've got the word for, you've got the thing inside whatever you're iterating over, but that's a complex sentence right there. I'm using a really technical word, iterate. So like I said, blank to just ignore it. For blank in range 3. So says this loop is going to run 3 times, and the colon basically says to Python, hey, get ready, we're going to indent. We're about to say there's stuff inside of this code. That's what the colon says. It says we're going to just simply say this is where we start a block. And other programming languages like Java, they'll do stuff like this. where they use those curly braces, as I say, to say, this is how you tell what's inside a for loop, right? That's how other programming languages work. But in those programming languages, you end up with lazy coders who do this. And this, when you have for loops inside for loops inside for loops, looks awful and is a terrible sin. It is absolutely terrible. And so so good programmers will make sure to indent to say, hey, this is inside this, and so we can simply digest what we're seeing a bit easier. And Python's like, well, if good programmers are already going to do that, we don't need those symbols. We can just use the white space, the space you don't see, the indentations, the tabbing. So that's kind of why Python can be a bit particular. If you do things like this, it'll yell at you about unexpected indents and forget to run, because those indents are meant to be, say, hey, this is a block of code. So we do hello and then world, and basically we do this. We print hello, then we print world, and we do that 3 times. Hello world, hello world, hello world. We don't go hello, 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 world, world, world. The entire block of code runs. And then we print done. Done only prints once. Why? Because it's unindented. It is outside the for loop, right? If it was inside, like this, right, it doesn't matter if there's a blank line or not here. If I just run this, it's going to go hello world done, hello world done, hello world done, because it says it's inside the for loop. I'm going to do exactly what you tell me. Okay? So let's now go ahead and move this outside the range of text and inside to the range of turtles, right? I can do stuff like bob.forward, and I can tell it to move 1 pixel, and I'll do that 3 times, and it's not really going to move. But what if I told it to move 1 pixel 300 times? And you can see it moves kind of a bit rather than moving all at once, right? Right, if I told it to do 10 tens, you'll see it basically moves a bit more smoothly than if I did 100 ones. Right? It's moving 1 pixel at a time, pretty slow. So we can repeat, basically we can tell a turtle to repeat things by using this for loop. Now, let's go ahead and think about so now, let's go ahead and rewind. This is why I love this bit, right? What were we repeating? What did we care about that was repeating? It was, okay, come on. There you go. It was these 4 lines, again, it was these 2 lines again and again. Move forward, then turn. Move forward, then turn. Move forward, then turn, right? So rather than copying and pasting this, we know we're going to be repeating this 4 times. So what I'm going to do is I'm going to write a for loop. For in range, I want this to repeat 4 times. And what do I want to repeat 4 times? I want to repeat these 2 things time. So I can either hit tab on them individually, or I can select them and then tab. Get used to using your keyboard commands, like on Windows. If I hit Control left and right, I can just jump by words. If I do Control Shift, I can select, and do left and right, I can select words. For a lot of you, this is complete. You know this completely, and it's blowing your mind. You know this completely, and it's unsurprising. Other people, it's blowing your mind. Just like doing Control backspace deletes an entire word. There's a lot of different things you'll get comfortable with. And if you ever accidentally hit a key press and it does something interesting, take note of it, right? But using Control Shift and moving left and right is very useful. There are different things you can do with Macs with the Command key, I believe. I just forget which key you have to hold down. Okay. But this runs 4 times, right? 4 blank in range. Repeat this 4 times, move forward, then turn left. And we'll see if we run this now. 3, 4. And if we up this to like 100, it's going to do it, right? 1, 2, 3. But because you know, it's the turtle, and it's just drawing, it's just going to be drawing over the same line again and again. Nothing wrong with that. You know. So telling it to do too many times is not really an issue here. It's going to take a while to stop, yes. All right. So, but now we have a useful format for doing this, right? If we want to do a shape over here, yep, and see what happened here? It crashed. This is not normally ever going to crash, but in your browser it will, just to make sure you aren't accidentally locking up your browser and then forcing you to close it, and then you lose all your tabs and you cry, right? Instead, there's a time limit of 30 seconds, and if it exceeds that, it will just automatically crash it for you, okay? But right now we have kind of a format. Let's go ahead and first off change some variable names to make this a bit easier, because otherwise we're going to get very confused, because we'll have sides and side. Because sides is a pretty good variable to describe how many sides there are, right? That's a useful variable. 4. And then maybe we'll call this variable s, because that's a kind of a classic math term. You can also call it length, but certainly not len. Len is important. So because of that, that's the reason I'm calling it s. So we're going to tell, and we kind of got a generic format here now, almost, that for blank in range sides, plural, for the number of sides we have, move forward s amount. This change that I made over here is called refactoring, where I just kind of changed some things in the code without actually changing what it does, but I changed like the variables I used for it. It's a common thing to do. Now, over here for the next problem, so I'm going to go ahead and share this if you need it. For the next problem now, drawing an octagon isn't so bad, because what am I going to do? Copy what I have, paste, and now what I need to do is draw the number of sides, right? Change the number of sides, and now it's going to go 8 times. So now what I have to do is figure out what is the angle that I need to draw for it to be an 8-sided shape, right? 45. How'd you figure that out? Because 135. That's too much math for me. No. We're going to be lazy. We're making 360-degree turn here whenever we do this, right? 90, 90, 360, right? Over here, this turned 120. 120, 120, 120, that's 360 as well. So however many turns we make, they're going to be equal, and they're all going to add up to 360. So I'm going to be lazy, right? There's 8 sides, right? There's 360 degrees total. Tell it to do the work. 360 divided by the number of sides, right? So what I did here is this gets us to, by the way, our 45. This gets us to our 45 degree, which is, by the way, we doubled the number of sides. So another way to get there is we doubled the number of sides. So we're going from 90-degree turns, so the turns need to be smaller. And we doubled the number of sides, so maybe half. That gets us 45, right? So 360 divided by 8 gets us this. Now, we also run into a slight issue over here where we are running out of bounds because the side is so big. But again, we're supposed to be asking the user for the side length, so we'll do that now. Input. Enter the size of the octagon's side. Right, and then I will run that, and I'll see, this is what I mean. I have to now pause what I'm doing to type in a number. And there we go. We've got an octagon. Okay? And now what's fun about this is because I've abstracted this so that to 360 divided by the number of sides, because I have abstracted this, because I've decided to be lazy with my math, It actually becomes easy to change if I wanted to do a, you know, I don't know what we call this, a 20-agon? Is that a dodecagon? Let's go with 30 as the side length. Oh my, that looks quite circular almost. Right? And now here's the thing. Remember our eventual goal here was we want to draw a circle. So let's cope with a few issues here. First off, it is impossible, actually. It's impossible to draw a perfect platonic ideal circle here, right? We cannot create an image that matches the formula of a circle, the pure mathematical image of a circle. Why? Because we're working with squares. Our entire screen is made up of tiny little squares. So there's no way we can actually draw a circle. We can just draw something that looks like it. And for humans, that works. We call that a circle, right? But, so ideally here, if we get, depending on the size of the image, right? If I go up to, if I go up to like 40 sides, it's starting to get to the point where basically we cannot tell that that is not a circle, right? And in fact, during COVID, right, my kid started, he started to finally talk, and he was, getting interested in, he was a late talker, so he started getting interested in math stuff because I talk about it a lot in class, and during COVID I have to teach online. And so we're talking about shapes, and so you start with the natural kids, like what's a 5-sided shape called? It's called a pentagon. A 6-sided shape, a hexagon. So of course he asked, what's a 1,000,000-sided shape called? And it does have a name because we like those things. It's called a megagon. And this is what a megagon looks like. It's a circle, right? It looks like a circle. But that's a 1,000,000-sided shape, right? That's my point being here. At some point, well before we get to 1,000,000, the number that we get here, well before we get to 1,000,000, the number of sides will start to resemble a circle more than an actual polygon, right? Than a regular polygon. And of course, because, again, like I said, Wikipedia is amazing for a lot of stuff, especially when it comes to mathematics. Very dedicated people started writing a whole lot about these things. A myriagon, see also, is a 10,000. Got it. Okay. And that's very thin. It's there, but it's very thin. Right? See? Very, very thin. Very, very thin. Because we really needed a SVG of this. Okay. So we can think, he actually goes over these points in the textbook over here, that we think of a circle being perfectly round. We can't achieve that, but we can trick our eyes into believing that. And that's what actually the circle function does in Python. It says, hey, you tell me how big you want the circle, and I'll figure out how many sides of a shape I need to draw to trick you into thinking that's actually a circle. Right? But it stands to reason, right? This to this to this, we are getting more and more circular the more and more sides we add. Okay? So choose a number like 30, 40, doesn't really matter. And that's how many how many sides we need to draw. So the second thing we need to do is that we need to kind of change the way we talk to the user and talk about doing this. And unfortunately, this requires math. Because I know a lot of you came in here to program and not do math, but surprise, programming has a lot of math in it. But also surprise, as we told you all earlier, you kind of get the chance to be a bit lazy with the math. Okay? You get a chance to be a lot lazier than you would in other contexts, because the idea here is the computer should do it for you. In fact, we have an entire class dedicated to that. That's called, it's by the math department. It's called numerical analysis, and it's all about, oh, that differential equation, that looks hard. Why don't I just use a computer to estimate the answer for that? And the estimation is going to be so close to the real thing I'd get, nobody's going to tell. That's the entire point of some of these classes. It's great. So the format for a question changes because circles don't have sides. It is just one thing, right? It is the circumference of the circle. So we are going to ask the user for a radius and then draw a circle with that radius, right? And just, and this is not to be, to demean you to think, oh, you don't know what circles are and stuff like that. It just really helps to have visuals, right? Because we've got this circle over here, and I do a poor job of doing it. Here's the center of the circle, and this is the radius, right? R. So we're going to be dictating this is how big this is, as opposed to something like a hexagon, where, again, I'm going to be terrible at drawing these things, right? We'd ask the user for the side length. So we need to somehow transform what we need to do is we got to ask the user for a radius and somehow turn it into drawing a shape, right? So a couple things here. What we need to do is so what are we going to do to draw a circle? Well, what we're going to do is we're going to start our turtle over here, and then we're going to go and turn around, and we're going to basically do little bit shape, he's going to just start drawing a little bit amount until he draws a circle, what appears to be a circle. Now, the total amount that he needs to draw is actually something we can answer. It's whatever the circumference of the circle is, right? The circumference being that border of the circle, right? So there's the formula, right? The circumference is equal to pi, or 2 pi r, or pi times the diameter, right? We're going to be talking about circles for basically the rest of the week, unfortunately, if you're not into geometry. So this is the total amount that it needs to draw. Now, fortunately for us, this is a given, so we can calculate this. Also, you might be asking, I don't see a pi on my keyboard. What do I need to do? I mean, you could import the math library, but honestly, for this, you can just use 3.14. It's fine. If you need to, you can go 3.14159. You can. You can add as many digits as you need. It's fine. Okay. So this is the total. So given the radius, this is the total amount you need to draw. So what you're going to do is you're going to do something very similar to what we did over here. The total amount of angle I need to draw is divided by sides. So the total amount that I need to draw is also divided by sides. So with that, you should be able to do that and be able to go from here to here. And I'm sure if I gave you an hour, you could do it. But really, we only have 15 minutes, so I'm going to give you 5 minutes instead of an hour, and then I will come back and show you the answer. So just take some time to think about it. Remember, what are we trying to do? The magical value we're doing is we are going and changing this to r is the radius, right? Input, enter the side of the circle, the size of the circle's radius. And then we need to use the circumference. It would help if I could spell radius, right? The circumference, which I'm just going to call circ because who's got time for that? Circ is equal to 2 times pi, and I'll just do 3.14, right? Or whatever, times the radius to get our circumference. And let's assume that we're drawing a 40-sided shape, but it can be whatever you want. And so, really, what our question is what to put here. Because everything else is the same. However, whatever kind of, we're pretending a 40-agon here is actually a circle. A 40-agon isn't a circle, but it should look a lot like it, right? And so, how big are the sides of a 40-agon? I don't know. 360 divided by 40. Let the computer do it. Right. you finish this, you can move on to the next part, which is the bonus portion, and I'm not planning on going over that part. It's just extra. It doesn't get graded for anything, but that's if you want to figure out that part, which is kind of the way the Python program, which is kind of a way that's a bit more useful. But once we're done with this, please don't leave, because I am going to go over a bit from the homework to just kind of give you pointers to help you out on how to do it. Yes. You figured this out already? But this part's important, all right? We gotta make sure that this gets converted, because Turtle was doing that automatically, right? And we were just kind of skipping over it because Turtle was letting us be lazy. All right, I'm going to go ahead and give us the answer. Yes? Question? Okay. Forward. So the total amount that the turtle needs to move is the circumference. That's the total amount he's going to draw. And it needs to be divided up, and each side should get an equal amount. So if we're dividing it up into sides, number of turns, it's going to be circ divided by the circumference divided by the number of sides. So if I say, hey, this is a 200, size 200, it's going to go off the screen. But yeah, that looks pretty circular. Let's go ahead and do 100 over here. Right? That looks like a circle. And I can change the number of sides to kind of, let's change it to a 14-agon. Right? That's not what it's called, but you get my point. We're going to draw a circle the same size, and we can see that it is not precisely a circle. Also, because of the angles, he doesn't precisely line up, but that's fine. But we can see that it changes in fidelity. Now, this part does not get graded, but be sure to fill out these parts. Now, this sounds like a dismissal. It isn't. Please stay put for two things. First off, health announcement. At least one, I've had multiple students who have said, hey, I'm not coming to class because I'm sick already, third point in the semester. I've had one student email me telling me they have already tested positive for COVID. If you are feeling sick, please stay home. Do not infect others. COVID and these various diseases are not a joke. In case you're curious as to why I use this cane, I caught COVID in summer of 2023. It robbed me not only of my balance, but my fucking hearing in my left ear. So, not a joke. Do your best to stay safe if you need to. If you're sick, get what you need. Stay home. okay? I'm never going to penalize you. If you're sick, if you tell me you're sick, I'm going to take your word for it. If you're sick for more than a week, that's where we start getting into, like, can you provide me with some documentation? But if you're feeling sick, it's fine. That's why I record the lectures, okay? So, not mad at anybody here. I just want you to, I didn't catch it from a student either. It's just like, just happened, okay? So, I just want you all to be safe. If you're sick, you can't be learning, okay? That's why I don't want you to come in when you're to an exam when you're sick, by the way, because an exam is supposed to be an accurate snapshot of your skill level, right? At that point, how well you understand how well you understand the material. I cannot get an accurate read if you are sick, okay? Same thing as has actually happened if your father calls you that to tell you if your father calls you at 4 o'clock in the morning to tell you your grandmother died. I don't want to see you that day. Okay, I'm not going to be able to get an accurate read. Tell me what's going on, send me an email, okay? And I'm going to be human, okay? So just please do us both a favor. Makes it a lot less complicated. Now, with that out of the way, by the way, I do try to keep this class PG-13. I am allowed one F-bomb a semester, and so I figured I'd deploy it now. That is what PG-13 is allowed, by the way, these days. So let's go ahead and go to Turtle Loops. So this is your lab for the week, and a lot of the stuff from today will be extremely relevant. We're going to go over more mathematical stuff. It's going to have a nice complex name, like the Madhava-Leibniz approximation. Don't worry about that. Lots of things in mathematics are way more advanced looking than they need to be. But here, all you need to know for today, for this week's homework, is what we got this week. Okay? Just don't name your homework turtle.py. It will make sure that you cannot run it. And this is just my biggest way I can tell you don't name it. Okay? Okay. The first task is Turtle Olympics, which will draw the Olympics ring logo. Okay? Which it needs to be in color. So look up how to change your colors of your turtle. The easiest way I found to do this is to create 5 separate turtles, one for each ring, and then use the circle function built into Python to draw 5 circles, right? And just have them just simply, then you can even make it look nice by making the pen the appropriate thickness. You can change the thickness of line, exactly like that. Now, the trick for the extra credit is making it picture accurate, which is that the Olympic logo interlocks the rings in a very specific order. Doing that is worth 10 extra points. So if you just simply draw the rings approximately and people will look like and go, yeah, that's Olympic rings, right? Let's do it. But if you want to actually make it like picture perfect, in that case, it's tedious. What you have to do is basically use those 5 turtles to like redraw over the parts and read a bit more of the circle documentation. The circle allows you to draw, the circle function in Python allows you to draw semicircles of a certain amount. So you can tell it, I only want to draw 10 degrees of the circle. And you can use that in conjunction with letting the turtle lift its tail up and down to just draw it accurately. And that's the reason it's not hard, it's tedious. That's why it's 10 extra points to do it. Okay. Turtle clock, very relevant to today's lecture, right? We're drawing an image that looks like this, kind of like the face of a clock. What I recommend doing is figure out how to draw this part right over here, okay? Which is, let's assume the turtle starts in the center, move forward a bit, then draw, move forward a bit more, and then use this command called stamp. And what stamp does is that, right, we mentioned that the turtle's got a little tail and he's drawing. Basically, stamp is him doing a little belly flop to make a full of ink, to make a stamp of himself, okay? So, do a stamp, and then return to the center, okay, using pen up and pen down accordingly. Now, the important thing to remember is that you've got 12 things here. They're all identical, they're identically spaced, so you should use a for loop to do this 12 times. So basically, once you do this, all this is figure out how to draw one segment, turn him the appropriate amount, and then toss it into a for loop that runs 12 times. That's it. Initials. This one's just fairly straightforward. Again, it's just kind of learning the mechanics. As long as your initials are recognizably the glyphs for your name, right? As long as I can point and go that and go, okay, yeah, that looks like an A, or that looks like a B. It doesn't have to be like picture perfect or anything. It's a bit annoying for the people who have a J, but in there as an initial, but tough. So again, it can be blocky, it can be circular. I'm fine with it. Draw shape. We did this in class today. And then finally, Triforce, which draws the Triforce from Legend of Zelda, which is just this image over here, which is, I just want you to reproduce this image, right? Now, there's two ways to do this, depending on how you want to look at it. The first way is to draw a big outer triangle and a smaller inner triangle, right? You can view it as big triangle inside little triangle where the points meet halfway, okay? That's one way to do it. The other way to do it is this is three small triangles, right? Triangle, and then a triangle where the corners, where this corner is, they meet here, and then this top triangle, this point and this point meet. And then this inverted triangle is just implied. Make sense? Right? So either way works. I don't care how you do it, because again, there's a lot of different techniques you can use. Okay? The for loop may be useful here. It's certainly useful here. And then it's probably not needed in inertials. And in turtle clock, it's definitely, I mean, you could technically do it by copying and pasting 12 times, but why do that when, you know, the entire point is to learn for loops? Okay? Each of these is worth 20 points, right? If you need to, like, if you can only do like the first four and need to come back to another one later, that's something that I totally allow. So, you know, take advantage of that. All right, with that, have a good day.